This is GATE 2023 question number 57, which is a kind of a mathematical physics vector calculus kind of a question. Means we have to use those particular techniques and to understand this particular question. So consider a vector field V consisting of velocities of points on a thin horizontal disk of radius r is equal to 2 meter moving anti-clockwise with uniform angular speed omega is equal to 2 radians per second about an axis passing through its center. Now if V is equal to some velocity modulus, that is the magnitude of the velocity, that is some speed, then which of the following options is or are correct? So it's a kind of a multiple selective question. So in the options r cap and theta cap are the unit vectors corresponding to the plane polar coordinates r and theta. And we may use these cylindrical coordinates, which we will use for this particular gradient and all those things. These are for your reference for the formulation. You can use those things. So we will see that how we can get into these particular options. So whatever is this given in this question, I have just drawn it here. So this is a disk, horizontal disk, and at the center, about the center, it is rotating in an anti-clockwise direction, which is shown by this particular arrow, and which is having some angular velocity omega, and the radius of the disk is capital R, and V is the corresponding velocity. So given conditions are this, that omega is given to be 2 radians per second, r the radius is 2 meters. Now we need to find out this V, because most of the things which are given, like the gradient of V, grad square V, then del dot V vector, these things we need to find out, and del cross V. It's a simple, you can see that all these gradient, divergence, curl, and what you call as Laplacian, all these things needs to be found out based on this particular problem which is given. Now we know that V is equal to omega cross r, which is known to us. Now r is some radial distance, some position vector. R is some position vector. Okay. So we will use the cylindrical coordinate system as given in the question, but instead of s theta and s phi and z which is given, we will use r theta or z or r theta or k, where r is this radial direction. This is r in some radial direction, it is moving. So this is r cap is the unit vector in the radial direction. Theta cap is this this particular movement, like here in this way, the cylindrical movement, the curvature is moving. So this is the unit vector in the theta cap direction, and z cap is the perpendicular direction, that is the k cap direction also. So it's a unit vector in the vertical direction. Now V therefore can be written as omega is in the k cap direction, as from this particular thing it is in the k cap direction. If you put the cylinder over here, so omega will be in the k cap direction, therefore we write V is equal to omega k cap cross r cap, because r is also in the radial direction, therefore r into r cap. So this is quite familiar expression. Now from here what we will write is that we combine omega into r and k cap cross r cap, which gives us a direction of theta cap. If you do it in this way, so k cap cross r cap will give you theta cap. So this velocity, as we can see here, is in the theta cap direction, in the curvature kind of a plane. So moving like this. So velocities are like this. Okay. So this is clear now. So this magnitude becomes omega into r, some arbitrary r, we don't know, some arbitrary r. Okay. Now because we cannot put here r is equal to capital R, which is given as 2 meters, because if had we put it, then we cannot calculate this grad V and all those things. We have to generalize some r, some variable r, which is varying. Then only we can calculate this gradient, divergence, curl, and everything. So first is we will calculate grad V, because these are the options which are present. These are the 4 options which are present: grad V, grad square V, del dot V, and del cross V, the curl. So first is the gradient. The first part is the gradient. So the formula in the cylindrical coordinate for gradient is given in that particular problem also, or you can remember also. So this is how it is written. So r cap, this will be delta theta, omega r theta cap, and this is the thing. So we will put omega r in all the places, because V is nothing but omega r, because that is the magnitude. Remember that gradient is always of a scalar quantity, and scalar quantity is the speed omega into r. Okay, so r cap delta delta r of omega r 1 by r delta delta theta of omega r. So we can see that these things will be 0 because delta delta theta of omega r is 0, delta delta z of omega r is also 0, but delta delta r of omega r is non-zero, that becomes omega only, and with an r cap. So this now is a vector because gradient is a vector quantity. So omega into r cap. Now we know that the value of this omega is given. So this will be 2r cap. Therefore, grad V is equal to 2r cap, and A option is therefore correct. So if I see this A option, we can see that grad V is equal to 2r cap, which is a correct option. But we need to check the other options because it's a multiple selective question. More than one options may be correct. Second is the divergence. So this is the divergence. We know that divergence is a scalar quantity, but V has to be a vector. V has to be put as a vector. Now V has to be put as a vector means what? V is what we have found out, omega r into theta cap. Therefore, this is the formula of the divergence in the cylindrical coordinate, which we will be using, which we have used here. So it is 1 by r delta delta r of, so the r cap component should be there, which is 0 here. Theta cap component is omega r, therefore I have put it omega r, and the z cap component is again 0. Therefore this is 0, but one delta delta theta of omega r is also 0. So this is 0, del dot v is equal to 0. Let's see what is the option del dot v given. Del dot v comes out to be 2, which is not correct. Therefore B is incorrect. Option B is therefore incorrect. Fine. This we have found out. The next thing is the curl. The vector curl, which actually tells us the rotation, how much rotation is there. So del cross V in cylindrical coordinate. So in all things we are doing in the cylindrical coordinate because it is given in the question, you may use the cylindrical coordinate, so we can use it. So 1 by r cap. Now remember that in the scale factor r for the cylindrical coordinate, let me write, for cylindrical coordinate, scale factors are 1, r, 1. So this is actually the multiplication of all the scale factors, 1 divided by the multiplication of all the scale factors, and comes out to be r into 1, that is r. So r cap is equal to, so this will be the curl, the determinant in which r cap, and the scale factor of theta is r, and z it has 1. Therefore this is the scale factor in for the r, this is the scale factor in theta, and this is the scale factor in z in the cylindrical coordinate. So we have to remember all these things. Del del r, del del theta, del del z, we are doing curl, and this is 0, and r has to be multiplied again. The scale factor has to be multiplied in this row and as well as in this row corresponding. So this is equal to 0. Now if you calculate this curl quantity, then it comes out to be 1 by r. Only the z cap component will remain, other will be 0. So z cap component del del r omega r square z cap. Therefore it will be 2 omega r because it's a differentiation, 2 omega r divided by r cancels out. So we get 2 into omega. Put the value of the omega, that is 2, comes out to be 4 z cap. If I see what is given in this particular question, it comes out to be del cross v is 4 z cap. So we have found out that it comes out to be 4 z cap. Therefore option C is correct. Right. And the last is the Laplacian. Laplacian is also of a particularly of a scalar quantity. So Laplacian, I have written here wrong. So this Laplacian is always of a scalar quantity. You cannot have vector here. So I just remove the vector sign here. I have to put the magnitude part, which we have seen that V is equal to, I'm sorry, just a minute. V is equal to omega r. So V is equal to omega into r. Only the scalar part has to be put here. So this is the formula of the Laplacian. Just we put, only we can see that the delta delta r term remains, all other will be 0 because delta delta theta, if you differentiate it with omega r, it will be 0. Delta delta z of omega r will also be 0. Only thing remaining is this particular thing, 1 by r delta delta r omega. So what I get is, so if you first do this differentiation, it comes out to be omega, again comes out to be omega into r. So this is what I have written here, 1 by r delta delta omega, so it comes out to be omega. So it will be omega by r. Now in the question it is given that at 1.5 meter, that is at 3 by 2 meters, what will be the what will be this Laplacian? It comes out to be 2 divided by 3 by 2 comes out to be 4 by 3. So we can see from this option, this is a and 4 by 3 at r is equal to 1.5 meters. Therefore, option D is also correct. Therefore, what we can find out that A, C and D are the correct options. So this question, only thing is that we have to remember, or here it is already given that how you will find out the curl and all those things. So we can easily find out this particular expressions and find out that what will be the values of the gradient, divergence, curl and Laplacian. And we found out that except for the divergence, which comes out to be 0, all other quantities are matching with the options. So these three, A, C and D, are the correct options. Thank you.